All right, so today we're going to be talking about the unit circle again, and this time we're going to be focusing specifically on three really useful angles in quadrant one. The first one we're going to be talking about is a 30-degree angle, which if you're working in radians is pi over 6. So drawing that in quadrant one in the circle looks like this. We drop a perpendicular line to the x-axis to make our right triangle. And we're just going to pop that right triangle out and remember that the hypotenuse is 1 because it's a radius of the circle and we're working in the unit circle. This right here is a 30, 60, 90 triangle. So using what we know about 30, 60, 90 triangles, we know that the short leg is half of the hypotenuse. Since the hypotenuse is 1, that means the short leg is just 1/2. And the long leg is the short leg times the square root of 3. So we get square root of 3 over 2 for the long leg. And then that allows us to learn that the cosine of 30 degrees is the square root of 3 over 2, because that's the length of the horizontal leg here. And the sine of 30 degrees is 1/2, which is the length of the vertical leg. Next, we're going to be talking about 60 degrees, which is pi over 3 if you're working in radians. Once again, drawing a little diagram of quadrant one with the angle, drop a perpendicular line to make the triangle, pop our triangle out, and remember that the hypotenuse is 1 because it's a radius of the unit circle. This is the same triangle as before. It's another 30, 60, 90 triangle with a hypotenuse of 1. The only difference is that it's oriented differently this time. So that means this time the horizontal leg is 1/2 and the vertical leg is root 3 over 2. Which means that for 60 degrees, the cosine of 60 degrees is 1/2, and the sine of 60 degrees is root 3 over 2. So same numbers as before, just in different places. And finally, we're going to be talking about 45 degrees, which if you're working in radians is pi over 4. So drawing a little diagram of quadrant one with the angle drawn in, I do realize that I forgot to close those parentheses. I noticed it as I was putting the pictures into this video, and trust me, it bothers me a heck of a lot more than it bothers you, but it's late and I'm not going to take all of the pictures again, so we're just going to have to grit our teeth and get through it. So here's our 45-degree angle. We draw a perpendicular line to make our triangle. We pop our triangle out and remind ourselves that the hypotenuse is 1 because it's a radius of the unit circle. And then this is a 45, 45, 90 triangle. Because it's a 45, 45, 90 triangle, both of those legs are the same length. We'll label them x. And we know that whatever x is, x times the square root of 2 equals 1. So x is 1 over the square root of 2, multiplied by root 2 over root 2 to rationalize the denominator, and we find that x equals square root 2 over 2, which means that both the horizontal and the vertical leg in this triangle are square root 2 over 2. So the cosine and the sine of 45 degrees are both square root 2 over 2. So using this, we now know how to find the sine and the cosine of these three very useful angles in quadrant one. In the next video, we're going to talk about how to use what we know about quadrant one angles to find sines and cosines and tangents of angles in other quadrants using something called family member angles. Thank you.